Good day everyone. Today we will be having video assignment number 1 and enhancement course number 1. And this video assignment is all about DC circuits problems. So we will be solving 5 problems and we will show the solutions with each problem. So our first problem is number 10. So the number 10 is calculate the length of the copper wire having a diameter of 1 over 16 inches and resistance of 2 ohms. Conductivity of copper is 5.8 times 10 to the power of 7 Siemens over meter. So we have here the choices. A is 229.4 meters, B is 218.2 meters, C 232.2 meters, and letter D is 248.1 meters. So first, let's identify what is the given from the problem. So the first given is the diameter, which is the 1 over 16 inches here. So the 1 over 16 inches will be converted into meters. So as we all know, 1 meter is equivalent to 39.37 inches. So we will just multiply it by 1 meter over 39.37 inches. So 1 over 16 inches times 1 over 39.37 inches, 1 meter, cancel the inches unit. So we have here the meter. So the answer is 0.001587 meters. So that is our value for our diameter in meters. The next is our resistance, and our resistance is 2 ohms. Next is our conductivity. So the symbol of our conductivity is in sigma form. So sigma is equal to 5.8 times 10 to the power of 7 Siemens over meter. So that is, Siemens over meter is the unit for our conductivity. Next is the formula. What is the formula we will be using? So this formula is from the resistivity formula, which is will be converted into the conductivity. So since we already have the given for the conductivity, so we'll be using the formula with conductivity. So the formula for the resistivity is resistance equals to rho length times length over area. So since our conductivity, or this sigma, is equivalent to 1 over rho, which is our resistivity. So therefore, our resistance is equal to length over our sigma times the area. And we all know the formula for area is if we have given the diameter, we have pi times diameter squared over 4. So we'll start to solve the problem. So in solution, so since we are calculating, or we will be calculating the length of the copper wire, we will use the formula L, which is length equals resistance times the sigma, or the conductivity of the copper, times the area. And we have here the given, so we will just substitute the given to the formula. Our resistance is 2 ohms. Our conductivity is 5.8 times 10 to the power of 7 Siemens over meter. And the area is pi times d squared, which is our diameter. So we have here 0.001587 meters squared siya, and then divided by 4. That is for the area. And to solve this using our calculator, we will be having the answer 229.4572182 meters. So the answer for the length, or the length of the copper wire having a diameter of 1 over 16 inches and a resistance of 2 ohms is 229.4 meters. So therefore, the answer is letter A. So our answer is letter A, which is 229.4 meters. And that is for the number 10. Let's proceed with the next number. We have here 27. The problem for the number 27 is a bank of cells having a total EMF, or the electromotive force, of 12 volts and negligible internal resistance is connected in series with two resistors. A voltmeter of resistance 5,000 ohms is connected across the resistors in turn and measures 4 volts and 6 volts respectively. What is the total current drawn when these two resistors when connected in parallel across the same EMF? Excuse me. So our we have here the choices: A, our 10 milliamperes, letter B is 18 milliamperes, letter C is 15 milliamperes, and letter D is 12 milliamperes. So the same process, we will be identifying the given. So we have here the EMF. This is the symbol of our EMF, or the electromotive force, is equal to 12 volts here. Next is the voltages of the respective resistance. We have 4 volts and 6 volts. And the voltmeter of resistance is 5,000 ohms. And this is our illustration. We have here in series form our R1, or our resistance 1, our resistance 2, and we have here our EMF, which is 12 volts. And in this illustration, we will be having here we'll just put here, label it as A, and here is B. And then, since in this area, we have here the 4 volts and the 5,000 ohms. So here, next, solution. So first thing to do is solve for the equivalent resistance. So for the equivalent resistance, we will have the equation 5,000 times the R1, which is this one, over 5,000 plus R1 plus R1 times R2. That is for the equivalent resistance. Next is the total current flow. The total current flow is, and the formula of a total current flow is from our Ohm's law, which is the voltage is equal to current times resistance. So since we are solving for the current flow, or the total current flow, we will have the formula I is equal to voltage over resistance. And this R is the equivalent resistance. Then we will solve this through substituting the values to our formula. So since we have here the V, voltage, that is our electromotive force, which is the 12 volts, and over our equivalent resistance, which is from this equation. So we have here 5,000 times R1 over 5,000 plus R2 plus R1 times R2. So in this solution, we will identify first the magnitude, or the values of our resistance 1 and resistance 2. After that, we will solve for the total current flow through in a parallel circuit. So this one, we'll just solving it through the series circuit. Next is I is equal to 12 volts over. So since this is addition, we will get the LCD, or the denominator for the both is 5,000 plus R1. So the numerator for the denominator side is 5,000 R1 plus 5,000 R2 plus R1 times R2. So since this denominator, we can reciprocate this and it will multiply to the numerator. So we have 12 volts times 5,000 plus R1 over the 5,000 R1 plus 5,000 R2 plus R1 R2. And then we can factor it out. So we have here, this side is factorable. So 5,000 times R1 plus R2. So this is the equation for our total current flow. Next is VAB. So this VAB is from this equation, from this illustration. Since here AB, so we will get the VAB through this formula, or the equation I times 5,000 R1 over 5,000 plus R1. And then substitute. So since we already have the value for our VAB, which is 4 volts, and equal to the I, which is from the previous slide, we have here this one. We will substitute this equation to the next from this next equation. So in this one, this is the I, which is 12 volts times 5,000 plus R1 over 5,000 times R1 plus R2 plus R1 times R2 multiplied to the 5,000 R1 over 5,000 plus R1. So next is this one will be cancelled. So we have here 12 volts times 5,000 R1 over 5,000 times R1 plus R2 plus R1 R2. So this is the first equation. This is our first equation. So next is the illustration for the second part. So next is this one. We have here the second illustration. So since we already have the first equation, we can just copy it or follow this one. So we have here the 6 volt is equal to 12 volts times 5,000 R2. So since this is the second equation, we will be using the R2 over 5,000 times R1 plus R2 plus R1 R2. So that is the second equation. Next is we will multiply and we will divide the first equation to the second equation. So we have here the first equation is 4 volts divided by 6 volts equal to 12 volts times 5,000 R1 over 12 volts times 5,000 R2. So since this denominator will be cancelled since they have the same denominator. And then here, we will cancel the 12 volts. And then the 5,000 also. It will be cancelled. So we have here 4 over 6 is 2/3. So, and R1 over R2. So, the third equation is R1 is equal to 2/3 volts times R2. That is for the third equation. We will be substituting in this form so that we can get our values for R1 and R2. So since here, we will be using the equation number 2. And then substitute. We are substituting in the equation number 2 the equation number 3, so which is the R1. So 6 volt is equal to 12 volts times 5,000 R2 all over 5,000. Since we have here the R1, so we will substitute it to 2/3 volts times R2 plus 2/3 volts times R2. So cross multiply. So 6 times 2/3 is 4. So we have here 4, then multiply the R2 times R2 is R2 squared. So we have here 4R2 squared plus the 5,000 times 2/3 times 6 is 50,000. So we have here 50,000 R2 minus we have here 12 volts times 5,000. We have here 60,000. So 60,000 R2 is equal to 0. So our equation here is 4R2 squared plus 50,000 R2 minus 60,000 R2. Since they have the same or the similar, we can just minus this one or subtract this one. So we have here 4R2 squared plus 50,000 minus 60,000 is 10,000. So we have here minus, this is minus 10,000 R squared. So we will be having, since this one travels away. So we have here 4R2 squared plus 50,000 R2 minus 60,000 R2. So we will just subtract this one. 50,000 R2 minus 60,000 R2 is negative 10,000 R2. So we have here 4 R2 squared minus 10,000 R2 is equal to 0. So multiply both sides or divide both sides by 4 R2. So since they have this similar, we can divide this both sides by 4 R2. So we have here 4 R2 squared divided by 4 R2. We have 4R2 squared divided by 4R2. We still have the R2. We have the R2 minus 10,000 R2. So cancel the R2. We have here the 2,500. So our R2 is 2,500 ohms. That is the value for our R2. Next is for the R1. We have here, since this equation is from our equation number 3, we'll just substitute since we already have the value for our R2. So R1 is equal to 2/3 times R2, which is 2,500. So we have R1 is equals to 1,667 ohms. So that is the value for our R1 and R2. So next is, we have here the two values. So we will be moving to the next illustration, which is in the parallel circuit. So the formula we will be using is from the Ohm's law, which is V is equal to IR. And then since we will be computing or calculating the current flow, we will be using the formula derived from the Ohm's law, which is current is equal to voltage over resistance, and substitute the given. Since we will be solving for the total current flow, and in this one we have here parallel, and as we all know, the formula or the way to get the total resistance is through this formula, which is 1 over R1 plus 1 over R2 and to the power of negative 1, which is the reciprocal of this one. So let's substitute. So our V is the EMF or the electromotive force, which is 12 volts, all over our R1, which is 1,667. So we have 1 over 1,667 plus 1 over 2,500 and the power of negative 1 or the reciprocal. And then we have the answer for our current 0.01199856029 amperes. And we will just get the answer 12 milliamperes. We will move 3 to get the milliampere, and we have 12 milliampere. Therefore, the answer is letter D, which is 12 milliampere, and it is in the choices. And that is the answer for the next number. And next, we will be moving to the number 44, which is, the problem is, if a resistor rated 5 watts, 6 volts is connected across a battery with an open circuit voltage of 6 volts, what is the internal resistance of the battery if the resulting current is 0.8 amperes? And the choices are A is 0.5 ohms, B 0.2 ohms, C 0.3 ohms, and D is 0.4 ohms. So we will solving this through identifying first the given. And the power is 5 watts, the voltage is 6 volts, and the current is 0.8 amperes. And the formula that we will be using is from the formula of voltage equals power over current. That is the formula for the voltage, since we have here the power and the current. And this formula is from the electromotive force, which is electromotive force is equal to the voltage plus the current times the internal resistance. So since we will be solving for the internal resistance, we will be transforming this formula or get the formula for the internal resistance. First, we will solve for the voltage using the formula voltage is equal to power over current. Our power is 5 watts and our current is 0.8 amperes. And divide 5 divided by 0.8 is 6.25 volts, and that is for the voltage. Next, so the formula of electromotive force is equal to voltage plus IR, or the current times internal resistance. And since we will be solving for the internal resistance, the formula is EMF minus voltage over the current. And our EMF is 6.25 volts minus the 6 volts over 0.8 amperes. And then the R, or the internal resistance, is 0.3125 ohms. And that is the answer, letter C. And that is in the letter C, which is 0.3. You will just in the choices we have here the 0.3. So therefore the answer, letter C, which is 0.3 ohms. Next problem is 61. So we have here three resistors, 2 ohms, 5 ohms, and 10 ohms, are joined in parallel, and a total current of 24 amperes is passed through them. Find the current and 5 ohms resistance. We have the choices: A, 6 ohms, 6 amperes, B, 3 amperes, C, 12 amperes, and letter D, 15 amperes. Given is, we have here the total current, which is 24 amperes. The resistance 1 is 2 amperes, 2 current. Resistance 2, 5 ohms. And the resistance 3 is 10 ohms. And the formula we'll be using is this one. IN is equal to IT, or the total current, times the R total over the RN. And this N is, it depends on us which current or which resistance we will be solving. And since here we have here defined the current in the 5 ohms resistance, so we will be solving for the I5. And this is our illustration. We have here the R1, the R2, and the R3. We have here 2 ohms, 5 ohms, and 10 ohms. And our current total is 24 amperes. And the solution, IN, this is the formula. IN is equal to IT times R total over RN. And since we will be solving for the I5, and the substitute, our I total is 24 amperes. Then R total, so in solving the R total for in the parallel circuit, we have here 1 over 2 plus 1 over 5 plus 1 over 10 times to the power of -1, which is the reciprocal of this one, to get the R total of the parallel circuit. And then the Rn is 5, our resistance, our 5 ohms. Next is we will use calculator to solve this one. So this one, our R total is 1.25 and divided by 5, and we will multiply it by 24. So our I5, or the current 5, the current in the 5 ohms resistance is 6 amperes, and that is letter A. So therefore our answer is letter A, which is 6 amperes. And that is the answer for the number 61. Last number is 78. So this is our fifth problem. So a length of a wire has a diameter of 11.7 millimeter and a resistance of 31 milliohms. This wire is passed through a series of drawing process, reducing its diameter to 5 millimeter. Determine the resistance after. So letter A, 880 milliohms. B, 917 milliohms. Letter C, 728 milliohms. And letter D is 930 milliohms. The given, so we will be identifying the given. First is the R1, which is the 31 milliohms. The D1, or the diameter 1, is 11.7 millimeter. So we have here the diameter 2 is 5 millimeters. Then the formula we'll be using is R2 is equal to R1 times the area of 1 over the area of 2 squared. And the area, the formula of area is pi d squared over 4. So the solution is this formula. So R2, or the resistance number 2, is equal to R1 times the area A1 over the A2 squared. And then R2, we will be substituting the values. So we have here the R1, which is 31 milliohms, and then the area of number 1, using the diameter number 1, which is 11.7 millimeter. So we have here pi times 11.7 millimeter squared over 4, all over the area of the diameter 2, which is 5 millimeters. So we have here pi times 5 millimeters squared over 4, and then close and open parentheses, we will squared. So to solve this one using our calculator, we will be in this area, we will be having the answer of 29.98219536. And then we will multiply it by 31. So we have here the answer for the resistance number 2, which is 929.4480562 milliohms. So therefore, the answer is letter D, which is 930. This is the closest value to our answer. So this letter D is the answer for the number 78. And that is all for today. So thank you for listening. And I am Princess Maylak Bayo, BSEE 3. Thank you.